Equations involving indices. Learning intention. Solve equations by expressing numbers as powers of the same base. Success criteria. I can rewrite numbers as powers of a common base. For example, 16 is equal to 4 to the power 2. 1 over 27 is equal to 3 to the power minus 3. Use index laws to simplify expressions. Match the powers on both sides to find the value of x. Check my solution in the original equation. Example 1. Find the value of x in each of the following. So what we want to do is solve for x. So 4 to the power of x is equal to 16. So we want to rewrite 16 with a base of 4 so that we can cancel the 4's and let the powers equal, and then we can solve for x. So we're going to rewrite 16 as a base of 4. So 16 rewritten as a base of 4 is 4 squared, because 4 squared is equal to 16. Now we can see on the left we have 4 to the power of x, on the right we have 4 to the power of 2. The base is equal, so we can cancel the bases. And we're left with x is equal to 2. So x equals 2 is the solution to part 1. So we were asked to find the value of x, and we got x to be equal to 2. Part 2, 16 to the power of x is equal to 64. So we're going to rewrite both of the big numbers in the same base. So 16, I'm going to rewrite as 4 to the power of 2. And then I'm going to have brackets around that, and I'm going to bring down the x. So 16, I'm rewriting as 4 to the power of 2, because 4 squared is 16. I'm going to put brackets around that, and then bring down the x. So then I want to rewrite 64 as a base of 4 as well. So 4 to the power of 3 gives me 64, because 4 by 4 by 4 is 64. So I have 4 to the power of 3 on the right-hand side. Now on the left-hand side, I need to tidy it up, so I'm raising a power to a higher power. So the rule is I multiply the powers. So I'm going to do 2 multiplied by x, and 2 times x is 2x. So a number times a letter, we stick them together. So we get 4 to the power of 2x. And that's still equal to 4 to the power of 3. So I'm just bringing down the 4 to the power of 3 on the right-hand side. So I have 4 to the power of 2x on the left, 4 to the power of 3 on the right. My bases now match, so I can cancel them. And then I equate the powers. So I'm going to have 2x equals 3. So I have 2x equals 3. And I want to solve for x, get the x on its own. So I divide both sides by 2. So x is equal to 3 over 2. So for part 1, x is equal to 2. For part 2, x is equal to 3 over 2. Part 3, 3 to the power of x equals 1 over 27. So we want to rewrite 1 over 27 as 3 to the power of something, so that we can cancel out the bases and let the powers equal. So 3 to the power of x just stays as it is. And 1 over 27 becomes 1 over 3 to the power of 3, because 3 squared gives me 27. So now I want, on the right-hand side, a big 3. I don't want a fraction. I want 3 to the power of something. So the left-hand side will stay the same, 3 to the power of x. And then 1 over 3 to the power of 3 becomes 3 to the power of minus 3. So I'm using one of my laws of indices. And if you're unsure on these laws, look at the video. 3.7 laws of indices. So this is one of our laws of indices from our formula book. A to the power of minus p equals 1 over a to the power of p. So we started with 1 over 3 to the power of positive 3. So the blue 1 is here in my formula, and the 3 in green was the p in my formula. So if in the formula the positive p becomes negative p, in my number, the positive 3 will become negative 3. So 1 over 3 to the power of positive 3 becomes 3 to the power of minus 3. And that's using this formula from my formula book. So now I can see I have 3 to the power of x equals 3 to the power of minus 3. Now my bases match, so I can cancel the bases. And I can let the powers equal. So I'm going to have x equals minus 3. So x equals minus 3, and that's my answer. That's my solution. Part 4. 25 to the power of x is equal to 1 over 125. So both of these numbers can be rewritten as a base of 5. So I'm going to start with the left-hand side. So 25 I can rewrite as 5 squared. So I'm going to have 5 squared with brackets, and then I have to bring down the power of x. So I'm changing the 25 to 5 squared. I must include brackets, and then I'm bringing down the power of x. Then on the right-hand side, 1 over 125 will become 1 over 5 cubed. And that's because 5 cubed is equal to 5 by 5 by 5, which is equal to 125. Now I have to keep going. On the left-hand side, I need to simplify. So I have 5 to the power of 2 raised to the power of x. So raising a power to a higher power, we multiply the powers. So we're going to do 2 times x, which is 2x. So on the left-hand side, I've got 5 to the power of 2x. Now on the right-hand side, I don't want a fraction. I want a big 5 with a power. So I'm going to change 1 over 5 to the power of 3 to 5 to the power of minus 3. So this again is our law of indices from our formula book that says a to the power of minus p is equal to 1 over a to the power of positive p. So 1 over 5 to the power of positive 3 becomes 5 to the power of negative 3. So that's coming from this formula here. Now we can see that our bases match. So I can cancel the 5s, I can cancel the bases. And now I let the powers equal each other. So 2x equals minus 3. So 2x equals minus 3. We want to solve for x, get x on its own. So we divide both sides by 2. So x is equal to minus 3 over 2. So that's our solution. X is equal to minus 3 over 2. Example 2. Express 81 over root 3 as a power of 3 and hence, which means using what you just worked out, solve the equation. 3 to the power of x minus 2 is equal to 81 over root 3, all raised to the power of 2. So we start off with 81 over root 3. We want to rewrite this as a power of 3. So 81 I can rewrite as 3 to the power of 4, because 3 by 3 by 3 by 3 is 81. And then root 3 I can rewrite as 3 to the power of a half. So now I'm dividing powers with the same base, so I subtract the powers. So I get 3 to the power of 4 minus a half. And 4 minus a half is 7 over 2. So I have expressed 81 over root 3 as a power of 3, and it is 3 to the power of 7 over 2. Now hence, which means using what we've just worked out, so using this, we are going to solve the equation. So hence, solve the equation. So I'm going to replace 81 over root 3 with 3 to the power of 7 over 2, because we already worked out 81 over root 3 is 3 to the power of 7 over 2. So I'm replacing 81 over root 3 as 3 to the power of 7 over 2, but I must then put in the brackets and bring down the power of 2. Now the left-hand side is staying the same. 3 to the power of x minus 2 is still just 3 to the power of x minus 2. So I bring down the 3 to the power of x minus 2, that stays the same. And then I was raising a power to a higher power, so I multiply the powers. So I'm going to do 7 over 2 multiplied by 2, which gives me 7. Now my bases match, so I can cancel out the 3's and let the powers equal. So I have x minus 2 equals 7. And solving for x, I get x is equal to 7 plus 2. So x is equal to 9. So I was asked to solve the equation, which means find x, get x on its own. And I did. X is equal to 9. Example 3. Express 16 as a power of 2. Express root 8 as a power of 2. And then hence, which means using your answers from part 1 and 2, solve the equation. 2 to the power of 2x minus 1 is equal to 16 over root 8, all raised to the power of 3. So part 1, express 16 as a power of 2. So 16 is equal to 2 to the power of 4, because 2 by 2 by 2 by 2 is 16. Part 2, I want to express root 8 as a power of 2. So root 8 can be rewritten as root 2 cubed, because 2 by 2 by 2 is 8. So then I've got the 2 to the power of 3, and I'm going to put brackets around it. And the square root, I'm going to rewrite as a power of a half. And then I'm raising a power to a higher power, so I multiply the powers. So I get 2 to the power of 3 multiplied by a half, which is 2 to the power of 3 over 2. So I was asked to express 16 as a power of 2. So 16 as a power of 2 is 2 to the power of 4. I was asked to express the square root of 8 as a power of 2. So the square root of 8 as a power of 2 is 2 to the power of 3 over 2. And then hence, which means using those two answers, solve the equation 2 to the power of 2x minus 1 is equal to 16 over root 8, all to the power of 3. So I'm going to write down 2 to the power of 2x minus 1, so that doesn't change. I'll just write that down as it is. And then I'm going to have something over something raised to the power of 3. So the 16 I'm going to replace with 2 to the power of 4. So my numerator here will be 2 to the power of 4. And then the root 8 I'm going to replace with 2 to the power of 3 over 2. So my numerator will be 2 to the power of 3 over 2. So now I need to tidy up the right-hand side. So the left-hand side stays the same. And then on the right-hand side, I was dividing powers with the same base, so I subtract the powers. So 2 to the power of 4 divided by 2 to the power of 3 over 2 becomes 2 to the power of 4 minus 3 over 2. So dividing powers with the same base, we subtract the powers. Now I have to bring down the brackets and the power of 3, so I'll come back to that in a minute. So now just focusing on what's inside the brackets. 2 to the power of 4 minus 3 over 2, I need to subtract the powers. So I get 2 to the power of 5 over 2, because 4 minus 3 over 2 is 5 over 2. So I still have the brackets around it, and I bring down the power of 3, and the left-hand side stays the same as well. So I need to keep tidying the right-hand side as much as I can. So now I'm raising a power to a higher power, so I multiply the powers. So it's going to be 5 over 2 multiplied by 3, and 5 over 2 multiplied by 3 is 15 over 2. So the left-hand side has just stayed the same. Now I can't go any further. I have 2 to the power of something on the left and 2 to the power of something on the right. So I've simplified as much as I can, and now I can cancel the bases. I can cancel out the big 2's. And then I let the powers equal. So I have 2x minus 1 equals 15 over 2. And now I'm going to do letters to the left, numbers to the right to solve for x. So the minus 1 comes over the equal sign and becomes plus 1. And 15 over 2 plus 1 becomes 17 over 2. And then dividing both sides by 2 to get the x on its own, we get x is equal to 17 over 4. So we are asked to solve the equation. So x is equal to 17 over 4.